Hello everyone, we're going to be making a basic smart contract that involves having a vault, adding users to this vault, giving it a name, and distributing the amount in that vault to the users evenly. So hopefully this gives you some insight. I know I didn't really get this when I first started, and I'm going to try and explain it as if I just started again, but explaining in much further depth than what is out there right now. And that's like the whole point of why I'm making this, is just so people can get the start that I wish I could have gotten. So first off, we're gonna go to Remix, just because it's a in-browser editor and we can deploy and just test really quickly. Here's the URL, remix.ethereum.org. As you can see, I've already made it. But I'm going to go through it line by line, instead of just copy and pasting, because that's all I've seen so far and it doesn't really help, especially when you're new. So we're just going to name this, if it wants to work. My computer doesn't like me. I'm going to click this, and we're just going to name this. If it clicks, oh my god. We're going to name this vault contract.sol. And basically what we need to do first is give it a license, so spdx license identifier, and then we haven't got a license, so we're going to make it unlicensed, and we're going to define our version of Solidity we're writing in, which is 0.8.5 is the most up-to-date one at the moment. We're going to define our contract, which I will call vault contract, and done. We've already made a contract. Easy as that. But we want to add some functionality and some data into it so we can actually make it somewhat valuable. But what we're going to do first, we're going to define a vault. We're going to define our vault. And we're going to do this by using a struct. And a struct is basically a container that holds different types and variables inside of it. Think of it like a grouping. So what's a good thing? So you have like a water bottle, right? You can put water inside of it. Let's just say you put water and some other liquid, like, I don't know, paint. As weird of a combo that is, because I have paint right next to me. But let's say you put different type of paints in it, and it contains these paints. And this is basically the same thing. It's a container for these types. So what we're gonna type in here is we're gonna have the address of the creator of the vault. And that's basically like their MetaMask wallet, like their public address, or it could also be a contract. It could be a contract as well, any address. We're going to name the vault with a string, and we're going to have multiple addresses with an array, a dynamic array, because you can add as many as you want. Not as many as you want, but the number is really big, and that's 2 to the power of 256. But we're going to have users, and then we're going to have uint256, an amount. The reason we use uint256 and not something like uint8 or uint88, 128, any of those numbers, is because amounts, you don't know how many coins someone's going to have. So like, for example, you're not gonna do 2 to the power of 8 because maybe someone has way more than 256 tokens, right? So we want to have the maximum, because I'm pretty sure every single project, or most projects, have a total supply using this number, which is a big number, so we want to match that. And we can also use this number for time as well. But if you want to be more gas efficient, you could use something like 2 to the power of 128, because you're probably not going to outlive this. you'll probably not be alive when it gets to this point. But if you want it to live on, if you want your contract to live on and be still functioning while you're not alive, then it's a good idea to do that. But if you want to be gas efficient, maybe do something lower like that. But in this case, we're going to use 22568 for the amount, and that's our struct or container, our vault container. And what we want to do next is make a 256 total vaults. So this is going to be how many vaults are in existence at the moment. And then we're going to map each of these vaults with a mapping like this. And basically what's happening is that we're mapping a uint256, so any one of these big numbers. So we're going to start at 0. We're going to start at 0 and we can go to that number. So this is pretty much infinite in a way. Not infinite, but it's a very large amount. So in this case, we're starting at 0 because we haven't declared like 1 or 2 or 0. If you do equals 0, that's going to cost gas. So it's actually cheaper to do this because you're not assigning anything to it. It automatically assigns it. And if you're using a boolean like choice or something, you wouldn't do equals true. You would want to do something that is automatically false, so you don't have to set that equals and spend extra gas. So total vaults, we're starting at 0, so that's why we're doing that. Cool. So we're matching 1, for example. This could be like 1 could be assigned to a specific vault, and we could have 2 assigned to a different vault. And each one of these vaults is coming from the struct, and these have different variables, or they could be the same. It depends on what people do or what they create. So think of it like a key and then a lock. A lock and a key. You're inserting. Actually, no. Think of this as like the key and this is like the lock. You're putting the key into the lock, and it's opening up this container. If you get me. And you can assign, and you can open up. You can use this key with this name, and this can be anything. This could be like storage vault or our vault, but in this case we're just going to do vaults. Cool. And we're also going to just give our users a balance, so we're going to assign an address to a uint256, and that's going to be the address of the user. Ooh. The address of the user and what's their amount, pretty much, that they're assigned. Cool, we're gonna make this public so everybody can see it and everybody can use it. Bang. Okay, so that's our data structures. We want to make an event as well because we're gonna have a vault distribution function. So we're just gonna add this, so whenever that function is called, this will be emitted, and anybody that is on the blockchain can see this. And then, for example, if I'm one of the users in this vault and the vault is distributed, I'll know that that's happened. I can look at my wallet and I can see that I have funds. I just got sent funds. But in this case, we're not using any money. We're just going to change this value to like different values, like 100 or like 500. It doesn't do anything, but it's just sort of like an explanation. You can implement your own tokens as well later. This is just for like learning purposes, I guess. So we're actually going to have a function that creates a vault now. So we're going to do function create a vault, and then we're going to have a string for the name, and we're going to do memory because we're not storing this. We're just using it real quickly, and then we're getting rid of it. We're using it, assigning it to this thing, and then getting rid of it, basically. String. This is name. String memory name. We're gonna have an address, all the addresses, and we're gonna use memory as well because it's the same thing. And we're gonna set the amount, initial amount. So we can do initial amount, and this is really long, so we want to actually format this a bit so it's easier to read, like that. And if it's not too long, it's just like 2 of these, and it's like sort of the length of this, you should just leave it. But this is getting kind of long. I'm also going to add returns, so it returns a value at the end of it, and this will be our vault ID. And this vault ID is what we would use here to check what's inside of this vault. So if we get returned a vault ID of 1, we can type 1 into this. This will create a function because it's public. It already creates a view function. So if we type 1 into that function, we'll be able to see what's inside of that vault. And I'll show you at the end. So with this create vault, we're going to be using vault, storage, vault. And basically what this is doing, it's going into the storage of this vault struct. And then we're assigning this value right here to vaults, total vaults. So we're assigning this value, which could be anything by the way, like our vaults. But in this case, I'm just going to do vaults because it's simple and compact. So we're assigning this right here. So then there's that number again, total vaults, which is a uint, which we can add here. So we're using this uint, and we're getting the vault for that uint, and we're assigning it to this value. Cool. And we use storage because we're going to be writing over whatever's in this. We wouldn't use memory. We would use memory when we're not writing over stuff. But since we're writing over stuff, we're using storage. And we're writing over this in a vault struct. So hopefully you sort of get that. And then basically we can do vault.creator equals message.sender. And that will write over this because we're accessing that storage. We're writing over that as the message.sender, which is us. Because we're the sender sending the message to this function that's submitting the transaction, and it'll get executed and it'll write over this. Cool. And then we can do vault.name equals name. This is doing the same thing. Oh. And then, oh, what's wrong here? This is vaults, my bad. Set that to vault. And then we could do vault.users equals users. And then lastly, we'll do vault.amount equals amount. So we've just set everything. Did I do that wrong? What's this? Undeclared identifier. Oh, initial amount, sorry. There we go. So we declared all these in here using this. And then we set it into the storage container of this vault. Hopefully that sort of makes things a bit clearer. And lastly, we're going to add onto the total vaults, doing plus equals 1. So basically what this is doing is adding whatever number this is to this. Another way you could do it is like total vaults plus 1. So you can see it's shorter and more concise. Cool. So we've set this vault to the first number, which is 0, because we haven't declared anything. So this is actually this. So our vault is declared to 0, and then this will make it 1 for the next vault. And then lastly, we're going to return total vaults -1, because we want to get that first vault, even though because we just set +1. And the reason we don't have this before is because then this marks the end of the code. So we wanted this at the last thing that we ever write. Awesome. So we just wrote our first function. And now we're gonna make a function called addAmount, where we're gonna have uint vault ID, which we just got one from making a vault. So we're gonna change this vault ID, uint amount, because we're gonna set this amount. I'm gonna make this public so anybody can do it. vault. We're going to do the same thing because we're writing over stuff. So vault storage, vault equals vaults. I know there's a lot of vaults, my bad. And then we can do that vault ID. So we're grabbing that vault again. And we're going to have a require statement this time. And this actually is like, in order for this function to pass or execute the next line of code, it would have to, this would have to be true. Otherwise, it will send an error message. But in this case, we're going to do the message.sender, which is us, because we're going to be calling the function. Message.sender equals vault.creator. So we have to be the creator of this vault. So if we create a vault, we are the creator and it's set here. And so what we're doing, we're accessing the storage of this vault ID we just entered, and we're checking if we are the message.sender, or I mean, if we are the creator, we, the message.sender, are the creator. And then we can have an error message like, not vault owner. And so if this is not true, we'll get an error message called not vault owner. Cool. And then we're just going to set the amount to whatever the amount was set. Awesome. So we just made our second function. Now we're going to make a last function here, and it's going to be called distribute. And basically distribute is going to do this. Vault ID, we're going to get a vault ID, we're going to have it public, and we're going to first do this, because we're writing over it once again, UN256. You don't have to do this every time. You could do it the long way by doing this. But as you can see, it's a lot more code, and it doesn't look as clean as if you were to just do that. Cool, so we're gonna get the amount. We're gonna actually, per user. I'm gonna write it like this: amounts per user equals vault.amount / vault.users.length. And basically what this is doing is getting the amount set in the vault currently and dividing it by how many users there are in this array. And so we're actually going to do this. We're going to do require vault.users.length is not 0, basically. Actually, no. No, it'll be fine. Nah, we'll leave it. Who goes? You can try and add your own requirements at the start, but I'm just gonna do it real quick. Do this stuff real quick. So we're gonna add a for loop as well, and we're gonna do uint8 because there's most likely not gonna be 256, more than 256 different users in this, so that's why we're doing the lowest uint. And we're gonna set that to I, and I is actually equal to 0, but we're just not setting it because we can do that, and it automatically sets to 0. And then we're gonna do I, if I is less than vault.users.length, and this is our requirement for it to do a loop. And then we're also gonna add onto I at the end of the loop. So when this number is less than the length of the users, so how many users there are, go through the loop. Otherwise, stop the loop, basically. Or don't execute. Think of this as like a require statement. And what we're going to do, we're going to do the vault amount takeaway. Oh, yeah, takeaway equal amount. So we're just subtracting the amount from the vault amount. Oh, I mean, amount per person, sorry. And then we're gonna have balance of our vault dot users of whatever number set here. So think of it like we're going into the vault and we're going into users, and whatever that number is, that's gonna be the user here. So if we had OX, that's one user, OX, two users, this will be 0, this will be 1. And so let's say if it's automatically 0, so we're gonna iterate through this one. Like, okay, so we're gonna fetch this user. Cool. And then we're gonna equal amount. Yeah, cool. So what we're doing, what's happened here? Amount per user, sorry, Jesus. So what's happening is that we're getting that user that I just explained before, and we're using that in this address, and we're checking what their balance is. But in this case, we're setting that balance to what we just calculated here per user. And then we can emit vault distribution to the vault ID amount times the vault.users.length. And this is just emitting, ooh, what's wrong here? Oh my god, amount per user. And we're emitting this event. So event and emit, this declares the event, this broadcasts the event, I guess you could say. Cool. And I want to get through an if statement as well. So, what can we do? What can we do? What can we do? Distribute. We could just add it here. So think of if statements as like require statements, but they're like conditionals, I guess you could say. So this is a conditional. So we could do, this is a really bad example, but it'll help you understand what it really does. So we can do like vault. If vault amount is greater than 0 or is not 0, execute whatever is inside of these brackets. And in this case, it's the for statement. And then we could do else revert and have an error message. No funds remaining. No funds available. And this would just be, you could make this a require statement at the top. So like vault amount, it's not 0, and then we could have that revert message up here. But I just wanted to show you what an if statement was really like. So that's why I did that. And you could also do this just to make it clearer. So else if, this is the exact same thing. And just do the opposite of that. If not 0 is 0. It's pretty much saying the same thing, just extra code. But else, if this doesn't execute, always do this. But if you have an if, like before, if whatever, if this isn't true, check if this is true, and if it is, do this, and there's no else. But if you make it so it's always one or the other, then it just makes it easier to read, in my opinion. Cool. So that's basically it. Congratulations, you just made a vault. A really basic one, but still a vault nonetheless. Cool, so let's deploy it actually. So we're going to deploy it by just coming over to the side, deploy and run. I'm going to click on that, and we're just going to deploy. Make sure you're in Java, script, VM, it's just quicker. This uses MetaMask, so let's just do that. Alright, easy, look how quick that was. Create a vault, we're just going to do this drop down arrow, and the name can be vault1. the users in this vault can be like this deployer address right here, and we can grab this other address like that, and the initial amount, let's say, is 1,000. Oh, okay, wait an error. Basically, I was doing it wrong. It just uses a specific, not the one quote, but a double quote. So we can just grab this again. Oh, I just deleted it. Put our address in, double quote, and then bang. There we go. So I just created a vault before, so that will be 0, and then this will be 1. So we'll check the 1 vault right here, and then we can see how it has 1 right there. And if we make another one and say this is vault 2, transact, vaults number 2 would come up as number 2. Cool. We can check the balance of our address, which would be 0. And we can distribute. Actually, we'll add some. We'll add vault to the vault ID 2, and we're gonna add 500. I'm gonna add 500, and we can check vault 2, and now it's now 500. We're not adding 500 because we didn't set. We didn't plus. So if we were to do that, it would add on to it. But since, actually, let's just do that. We'll restart it. So we can deploy it. Again, create a vault. And this will be vault 0. We'll get our address. Do that. Double quote. And then initial amount 1,000. Vaults 0, because that's the first one. And we're adding 500 to vault 0. And that's 1,500. Cool. And then we can check the balance of ourselves, which is 0. And then we can distribute from vault 0. But let me do this real quick. Will be a different, we won't be the owner. So when we press distribute, it won't work. Okay, it will work. And that's because we didn't set a require. I thought I set this here as well, but no, it's only for the add amount. So if we try to add amount to that one, it would fail. See how I get the revert, and then the reason, and that's why. Cool. So that's basically the vault contract. I hope you learned something. I hope it wasn't too bad to watch. Yeah. Have a good day. Take care.